A very good afternoon to all the panelists and to all the viewers online. A warm welcome to all to this fifth session of Power Plant Summit 2020, which is on environment management for thermal power plants. And to lead the session, we have our session chair, Mr. Prasad Rao. Welcome and thank you for joining us, sir. May I request Prasad Rao, sir, to kindly lead the session, take the session forward, sir. Thank you, sir.
Okay. Thank you very much, Mr. Sanjeev. This is session 5 of Power Plant Summit 2020. This is the 16th edition. Because of the present situation, it is being conducted online. Yesterday we had interesting sessions. The theme of the summit, as you all know, achieving world-class standards for thermal power stations through improved energy efficiency, environment management, and flexible operations. Yesterday, we had very interesting topics we had seen. One is on flexible operation and how NTPC has done this, and they've shared their valuable experience. And another session was on environment management for thermal power station as a whole, and R&D in CO2 utilization technology, and a holistic approach for power plant emission controls. And a session was also on ultra supercritical technology and best O&M practices. Today on the session 5, we will discuss about environment management. The team of panelists are with us. We initially will hear from Isgec about FGD, followed by NOx control from Hans George and Arup Shukla. Then zero liquid discharge from Mr. Deep Das, GMR Aurora, and followed by NOx controls from the thermal power station from Fortum Group. Finally, Mr. Sudhir Dhaya from NTPC will share his strategies followed for environment management and action plans. So let's start the first session with Isgec group, and they have about 20 minutes time to go through the FGD technologies, what are the options available, how they are going to take it forward in the Indian context. Okay, we'll go ahead. Mr. Amit and Soumik will join us from Isgec.
So we have already joined. Yeah, I'll just share my presentation. Just a second.
Mr. Saha, I request you to share your screen.
Yeah, is it visible now?
Sir, the application is visible, but please share your screen rather than the application.
Okay, just a second. Is it visible now?
Yes, sir, you can put it on your screen and we are good to go.
It's fine now?
Yes, sir.
Yeah, okay. Thank you very much, sir. Thanks a lot, and thank you for giving us this opportunity to present on this platform, which is being attended by all the dignitaries from our colleague companies, associate companies and all. Myself, Soumik Saha, and I am also joined by our my colleague, Mr. Amrit Haldar, who is our head proposal engineering. I will just give a brief introduction of what we are offering, and I'll hand it over to Mr. Haldar for the technology presentation. Actually, based on these emission norms given by the government, there were a lot of tenders in the market recently for wet FGDs. And the implementation is going on. NTPC is front-ending the implementation of FGDs in the Indian market. And we have also secured some wet FGD orders from NTPC and are currently executing 2 wet FGD orders for Kudgi and Gadarwada of around 4,000 megawatt capacity. We also have a technology tie-up with Babcock Power Environmental for wet FGDs. But all of us know here that mostly the prevalent technology that is being used for SOx emission control is wet FGD. However, less talked about, but efficient technology available in the world market is also CFB scrubbers, like circulating fluidized bed scrubbers, also known as semi-dry FGD technology. So we also have this technology tie-up with Sumitomo SHI Foster Wheeler, Finland, and we have this technology from them for the Indian market. We are also executing a project for Hindalco, Mahan 1 into 150 megawatt unit based on this technology. With this introduction, I'll just hand it over to Mr. Haldar to make the technology presentation.
Good. My name is Amrit Kumar Haldar. So I am working in Isgec and I am looking after proposal activity of FGD system. So I'll just start technical presentation. So what today we are going to present is basically it's a circulating fluidized bed scrubber technology. So it's called semi-dry FGD. Why it is called semi-dry FGD is we inject the water in the reactor, but we don't saturate the flue gas. That means we inject much lesser quantity of water, and we use this water to achieve the temperature which is effective for the reaction. So coming back to this now. What are the item involved in this? So first is what we have shown is the absorber in the right hand side, if you can see, and there is a fabric filter. So this can be ESP also, but mostly it is fabric filter is used. So it's there. Flue gas will enter from the bottom of the scrubber, and then it will travel up, and then it will enter to back filter, and then from back filter clean flue gas will come out to chimney. Now in this circuit, there is a recirculation which is called solid recirculation. So whatever solid is going to back, that will be collected and recirculated back to the absorber. Idea is why it is done, because we want to utilize unused lime in this circuit. What is otherwise going to pass the system. So this circulation system is basically to make it effective or to have more residence time for proper combustion and lesser wastage of reagent. So typically we use reagent in this technology. Maybe it could be sodium bicarbonate, it could be hydrated lime, or it could be quick lime, which is converted to hydrated lime. Right. Okay. So this is what we are showing the schematic. Typically, a control is very simple here. Here there is an independent water control which maintains flue gas temperature, which is optimum for the reaction. And then another control circuit is main control circuit is solid recirculation. This solid recirculation is maintained for proper reagent utilization. So and then we have limestone injection control, that is through SO2 feedback. We take feedback from SO2 and we feed hydrated lime of required amount to control the same. So this is very simple control with respect to wet FGD. So this is what wet FGD, I think everyone knows nowadays wet FGD. So this is very complicated control circuit, and footprint is quite large. So this is basically lime preparation system, which is a separate system. Then we have dewatering system, which is another big system. Then we have recirculation system and all other than absorber. So this all different circuit has got independent control system and a lot of equipments are involved. So this is quite complicated with respect to the semi-dry FGD system. Now, if we compare this, wet FGD with CFB FGD and SDA FGD, what we are showing is this, it's not really a CFB, but it is semi-dry, another type of FGD, dry FGD system. So let us compare with wet and CFB. SO2 capture in both can achieve good amount of SO2 capture. Water consumption, it is in CFB absorber, it is much lower, so it is beneficial here. Fuel flexibility is, both the technologies are having fuel flexibility, so it's almost similar. And then fine particulate capture. Since air back filters are there in semi-dry FGD, it can capture solid to a large extent. So it has got better control on particulate emission. Then higher SO3 capture. So in this semi-dry FGD, SO3 can be captured in a large extent. However, in wet FGD, it can be 30 to 40%, depending upon the situation, may go maximum 50% or so. So here in dry FGD, we can go even 90% plus SO3 reduction, so which is beneficial for the downstream system from a corrosion perspective. Then mercury capture we can have in semi-dry FGD with activated carbon injection, but in wet FGD this facility is not there. Footprint is compact because a lot of system, lot of less systems are required for semi-dry FGD with respect to wet FGD, and maintenance is very less because it is very simple, and corrosion perspective it is much lesser than corrosion and abrasion perspective much lesser than wet FGD.
Also, I would like to add here that in this system, like in wet FGD, a wet stack is not required. So you do not need to like modify any modification in the existing chimney, or you do not need to add any wet stack. You just have to install the FGD and can have the existing stack running as it is.
So this is what we have explained. This is the CFB scrubber where solids are getting recirculated. This scrubber is designed such a way we get around 4 to 6 seconds residence time, which is good enough for proper reaction of the flue gas. And then we can have very low operating range or turn down for this technology by using the recirculation of the flue gas. Then maintenance perspective, it is much lesser maintenance is required with respect to wet FGD. And then multiple venturi scrubber, it can be designed up to 800 megawatt unit.
We have the largest reference of around 500 megawatt unit.
So this is what we previous slide we have shown around 4 to 6 second residence time for the flue gas. Here we are showing around 20 to 30 minutes solid retention time inside the loop, which is adequate for proper utilization of the reagent. Then high reliability because no complicated items are there. Then bagged house can capture very high dust burden. And here we do not have a limitation of inlet dust like wet FGD. If we increase the inlet dust to wet FGD, this is going above certain value, it will start creating problem in operation, maybe for several reasons. There could be erosion because of high ash. However, in this technology, we can accept much higher ash dust burden, and those dust can be collected in the back filter, and at the outlet we can achieve much lesser dust emission. And dry sorbent, it is easy to handle. In wet FGD we get gypsum, so a lot of processes are involved to make it dry. Here you can get dry byproduct from the system itself. So bag, when we talk about bag, we have different options, different type of bags depending upon the temperature, acid resistance, alkali resistance, abrasion resistance, PM emission requirement, depending upon particular project, what are the critical parameters. Based on that, we select the bag which is suitable for that particular project. We have done one case study for 500 megawatt PC fired plant for firing Indian coal. So where we sulfur has been considered as 0.6%, we have considered tariff 3.85 rupees per kilowatt hour. We have considered plant utilization factor as 85%. Scrubber flue gas flow we have considered 2836689 meter cube per hour. And SOx and PM emission we have considered 100 for SOx and 30 for SPM mg per NMQ. Limestone cost we have considered 1,750 rupees per ton. Hydrated lime we have considered 6,650 rupees per ton, and water cost we have considered 56 rupees per meter cube. And for byproduct we have considered 0 for both the cases. Now if you come to this slide, we have done this comparison with respect to the limestone consumption, by reagent consumption. So that CFB scrubber is consuming little bit more reagent than wet lime. Water consumption is significantly lower for CFB scrubber. Byproduct generation is also much lesser for CFB scrubber. Power consumption is slightly more for CFB scrubbers. However, Wyndham staff requirement is much lesser for CFB scrubber, and maintenance time or downtime is much lesser than wet scrubber. If we come to cost part of it, we can see reagent cost. It is high in the CFB scrubber. However, for water it is lesser. Byproduct we have considered both cases, it is nil. Then loss of generation we have worked is much better situation for CFB scrubber. Wyndham and staff and maintenance also much better situation for CFB scrubber. So overall, if we see for 15 years NPP operating cost, this CFB scrubber is becoming optimum solution with respect to the wet FG2 technology.
Majorly, this is an optimum solution for those power plants which are of lower unit sizes. We can see for wet FGD, the cost for lower unit sizes is close to 1 crore per megawatt. Whereas we can achieve with this technology, we can achieve a capex of around 0.5 crore per megawatt for those lower size units like 150, 200, up to 300 megawatt units.
Another thing is this semi-dry FGD can capture SO2, SO3, HCl, HF, HG, PM, and all other constituents. Then high fuel flexibility. Anyway, this is also for wet FGD. It is there. And another thing is very fine particle. It can be captured because of bags are there in this semi-dry FGD. Gypsum is not generated. Byproduct is generated, which is much lower than quantity wise. It is much lower than the gypsum quantity.
Soumik ji, you have only 3 minutes more.
Okay, water consumption is lesser. Capital cost is lesser. So in overall, that previous slide, what we have shown, it will be beneficial for small size unit and higher size. So some of the reference plant, this is in US 420 megawatt plant, equivalent 520 because of site correction. So this is then another plant is 2 by 350 megawatt plant. It is in China. Another plant we have shown 2 into 300 megawatt again in China. Then again 2 into 300 megawatt in China.
All these plants we can achieve around more than 95% removal efficiency as well.
Then this 2 into 60 megawatt in Germany and 2 into 20 megawatt we have shown in Holland. So this is Somocolin 2 into 225 megawatt CFB. And this is what Somik was explaining. We are executing 1 into 150 megawatt for Hindalco. And this is the scenario. CFB scrubber supply design wise. If you see 66% in Europe, we have supplied 33% in China, 1% in US. Also, with respect to the boiler, 47% is the coal-fired boiler, and 39% is the waste boiler, and biomass is around 8%, and fuel oil is around 6%. This is the global scenario for this technology.
Yeah. Thank you, sir. Thank you. Your voice is not audible, sir. Voice.
Sir, please unmute, sir.
Yeah.
Hello, you are able to hear now?
Yeah.
Thank you very much, Isgec team. And the questions will be taken at the end of the session. Now I request Mr. Anup Chukla and Hans George Conrads from Promecon to take over the session 2.
Yes, hello.
These are NOx controls.
Can you hear me?
Yeah, sure. Please go ahead, sir.
Yes. Thank you very much for the invitation. I really appreciate the opportunity to talk about our technology. Let me quickly share my presentation with you. Can you see my presentation?
Mr. Hans, can you please share the screen rather than the application?
Yes, of course I can. Hold on. I can share. Yes, I can share this one. Can you see that now?
Yes, sir. Good to go.
That's fine. Okay. Well, then let's start off. What I'm going to talk about today is the primary measure to increase your efficiency, to lower your NOx, as well as to make your unit more load flexible. These are the big 3 things that we have been doing in the past in Europe and elsewhere. And I would like to show you how we do that. It is all centered around the primary measures that you can take to optimize a boiler. And before I go into our technology, I would like to go a little bit into the current problems that you can find on nearly any boiler in the world. I have seen many Indian boilers, I've seen other Asian boilers, and they all come up with the same problems. And these problems are the reason for efficiency loss, high NOx, as well as inflexibility to run the unit up and down, for example, when you have additional renewable energy in the grid. So let's first look at a typical thing. When you look at an air heater, let's go from the back. I start from the back of the boiler and I will go up to the front of the combustion to find the problems, the reason for the problems. When you start at the air heater, you can usually see an imbalance in O2 from the left side to the right side. I have rarely seen an air heater that is really balanced. And the reason for the imbalance that you can see is the maldistribution of airflow in the boiler and the maldistribution of fuel flow in the boiler. So these are 2 things that are the main reasons for that. And the first indication is an imbalance of O2. When I see that, I usually go on to see the superheater section. And on the superheater section, you can easily see the imbalance in attemperation water flow. Here you can see on the yellow circles, left side, 70 tons per hour of attemperation water, right side, 0. Right? So you have a huge imbalance between left side and right side. And this is usually a big indication of thermal maldistribution, and thermal maldistribution originates from coal maldistribution. The coal carries the heat input into the boiler. So if you have a difference in a temperation water flow, you have most likely a difference in heat distribution. Now go to the next picture. How much does that cost you? How much is the loss that you have? And I have just made a typical picture for a boiler. I've assumed $70 per ton of coal. In India, it may be only $50 per ton of 40. It's a linear thing. But if you go through all this and you assume a full load operating hours per year, a 700 megawatt unit that is considered in this case 700 megawatt electric, a net power efficiency of around slightly below 40%, you would end up with your normal excess air ratio of 20% or 18%, with a potential of optimization that can be seen here. If you reduce the excess air by 4%, if you reduce your fly ash, your unburned carbon content in your fly ash and your NOx, you would easily come up to a fuel saving of $1 million per year. Now, this is for international coal. If you have Indian coal with a much higher ash content, then your unburned carbon reduction will be much lower. Only a few tenths of a percent will give you a similar saving in coal. Why am I saying that? The potential of savings just by optimizing primary settings on your boiler is gigantic, and it's efficiency, NOx, and load flexibility. Now let's go into the reasons. Why do you have these problems? Why do you have these heat distribution problems in your boiler? And the first thing that I look at when go into a power station is I take a look at the mill operation. Here you can see a typical screen for a milling plant. You can see the silo, you can see the feeder, and you can see the mill. The values that I look at are the following. I look at the coal feed, I look at the air feed, and I look at the delta temperature. Why am I doing that? If you have the same coal going to the mills, then the enthalpy loss of the air per ton of coal should be the same on every mill. Because most of the enthalpy loss comes from the evaporation of moisture, right? Now let's look at that. In this case, we have 5 mills that we're looking at, and we look at the specific heat consumption per ton of coal. Now, as you can see in this power station, every mill is completely different in heat consumption, right? The laws of physics for every mill, however, are the same. So this should be the same, but it is not the same. Well, why is it not the same? You either have wrong primary air values, or you have wrong feeder values, or both values are wrong. You have wrong feeder and wrong primary air. That's what I usually find in power stations. And the result is that you have a wrong fuel input into your boiler. So that's one important finding. And if you go to your power station, you will find a very similar thing. Now, the second thing that we find frequently, your primary airflows are simply wrong. And the reason for that is that you have most of them measured by delta pressure. You have a venturi, you have an impulse line, and you measure the delta pressure over your venturi. Why is that a problem? The problem is that the impulse lines start to clog with ash and dust. And over time, you will get a drift of your measurement. Now look at this brand new Alstom boiler in Germany. Look at the red line, which is the delta P indication, right? Everyone can see that at the middle, the red line starts to swing and get very noisy. In this case, the user has cleaned the impulse lines to get a nice signal again. However, if you look at the blue line, which is the damper controlling the air, you can see the damper before cleaning was higher than after cleaning. Every delta P measurement drifts, and in your power stations, all your delta P measurements are drifting. There is not a single delta P measurement that is not drifting. And that's the second big finding. So your feeders are wrong and your airflows are wrong. And that's the reason why you have high NOx, low efficiency. How do we solve this? Promecon, first of all, has introduced an airflow measurement, which is now part of most German new coal-fired power stations. It is a digital system that measures the airflow not by delta P, but by a digital way, which is drift-free. Drift-free. No drift, always accurate. How do we do that? We have two sensors aligned, and these two sensors measure the electrification of the airflow. Let me show you this. You have a duct, and in this duct, you have charged particles. These are the ash particles coming from your air heater. These are the particles that are your problem with the delta P measurement system. With our sensors, we are measuring the electrification of these particles. And as more particles pass by one sensor, we can see more electrical current being induced on that sensor. Now, as we use two sensors in series, we are inducing an electrical current on two locations. You can see with your own eyes that these two signals are very similar. However, these two signals are time shifted, right? So what Promecon is doing, we are calculating the time shift between the two signals. So we are measuring a time shift between two sensors. So time and distance of the sensors gives you velocity, right? So actually, in a nutshell, our systems measure velocity in a digital way by time shift. And by this, you have an accurate velocity and airflow reading over your whole boiler, over all 20 boilers, all 20 burners, over all 20 secondary airs, over all the mills. And that allows you to have the correct airflow distribution in the boiler. That's the first very important point to optimize your boiler. Now let's come to the next problem. When you look at your mills, this is what you see. On every mill, your feeder shows the exact same coal input to the mill. Don't believe that this is correct. Your feeders are drifting as well. Every operator in a power station knows that he has to correct the feeder lines from time to time. So you are putting something into the mill, you are always getting out less because you have moisture evaporating. But more important, the coal output of your mill is different for every mill because your feeder input is not accurate. You do not have the same output on every mill. That's a fact. That's what you can see when you do the enthalpy calculation and the mass energy balance, right? So what do we do to prevent that? Promecon has a system that can measure the coal mass flow out of the mill in real time. So we can tell you how many tons per hour or how many kilograms per second are coming out of your mill right now. And this has a huge impact. You can now really level out your mill output. You can also have a better distribution of coal in the boiler by reducing the imbalances. And the real-time output also allows you to increase load flexibility on your boiler. I will show you an example of that at the end. The way the system works is very similar to the airflow system. We measure a velocity by cross-correlation, but in addition, we also measure the coal concentration by a microwave resonance technique, a patented technique that has been applied to thousands of burners. And this technique allows you to see how much is your coal concentration on each pipe. So coal concentration multiplied by velocity gives you coal mass flow kilograms per second for each pipe of the mill. Now, this is an important part, a new technology that we're currently brought onto the market, and this technology allows you to create a real-time coal output signal from your mill. Why is this important? You will see that the coal output that comes from your mill is fluctuating all the time. Your mill is pumping. You don't have a very solid and clean signal out of your mill, not like your feeder. Your output signal is very noisy. Now, if you try to smooth that signal and use it in your DCS system, this is very difficult. For this reason, Promecon have designed a new state controller, especially for spindle mills. And this state controller can now completely give you a feeder demand signal in order to control your mill output in real time. And before I go into too much details, I don't have the time. I will be happy to answer questions later by mail. Let me just show you how it works. The mill control model uses our co-flow and our PA flow as inputs. It also uses PF demand, mill DP, and mill outlet temperature, and some other parameters to come up with an exact coal PA demand, feeder speed demand, and real-time PF flow estimates. What does that mean for your mill? Let me show you 2 slides what that means. The first slide, when you start your mill, look at your mill output demand. This is the lowest signal. This goes up in a step by step. Now, when you try to get the real-time value close to that, look at how your feeder rate will have to overshoot in order to reach that. So your feeder will be controlled differently than it is controlled today. Let me show you what that means for mill to mill. Today, this is the way you control mill by mill. You have the same feeder setting on each mill. In the future, you will control like this. You will have different feeder settings on each mill, but you will make sure that the coal output of each mill is the same. And this helps you to control the coal much better in the boiler. Now, since we can measure the coal output on each pipe, we can also correct the coal imbalances on each pipe. This is another big contribution to lower NOx. We do that with an adjustable flap damper that we install on the top of the mill. It looks like this, right? Easy installation. And after you install this, you can then correct the imbalance on a burner by burner basis before and after. And this is how it looks like in real life. This is before, this is after. This was done on a Danish power station and optimization of coal flow. And this is your impact on NOx. You can come down from 500 milligrams NOx to way below 450. You can even go down to 400 milligrams of NOx just by better burner tuning. This is the best way. You don't need any ammonia, no SCR, no SNCR. This can be done by a complete control. But you have to install coal flow and airflow both in order to have the right control. This is also what you will find in many of your horizontal lines. You have instabilities of your flow conditions, and they can easily be corrected by the correct primary airflow selection. This is another very important feature to stabilize your combustion. Now, since my time is running out, I would like to show you one more great thing that for the big energy system of India will play an important role in the future. You will have more renewables in your system, more solar, more wind. Now, what happens? If you do that, your coal-fired units will have to ramp up and down, and you will have to do load following. Please have a look at the left upper picture. When you do this, you have a huge fluctuation in power and also boiler pressure because it's very hard to control your mills. Why? Because you are controlling your mill feeder. With Promecon, you are controlling the mill output. We give you a feeder demand signal in order to ramp the unit down and up much more smoothly. And on the lower hand right-hand picture, you can see the effect of a better boiler control. Much less boiler swing, much less boiler stress, and faster gradients And these are the things you can do with a better state-of-the-art control of airflow and co-flow. This is where we have done this. Our experience in power stations, steel plants, and cement plants. You can see a lot of green. In India, we have supplied co-flow systems to a lot of new projects, Maya, Solapur, Garavara. At least 6 new plants have been retrofitted with our co-flow. And I'm looking forward, when these plants go into operation, to work together with NTPC on optimizing their units. NTPC have purchased a lot of new technology with their new units. So in the future, they will be able to upgrade them. And for all the existing fleet, I think that we have the right solution to take your NOx down and to increase your flexibility by primary measures of combustion optimization. Thank you very much for your attention. And if there are any questions, I'm happy to take them.
Thanks, Mr. Hans, Josh. A very, very interesting and very innovative way of controlling the airflow and fuel flow. And being a control and instrumentation engineer myself, with over 40 years in power sector, I'm finding it very, very interesting. And wherever I meet people, because I have a lot of interaction with the power stations across the country, everyone is having the same problem. And in my 40 years of experience, I've been facing this sort of a problem throughout. So with your technology, I'm very much impressed. I'll see that a few more places that is installed. And I would like to see, when you are commissioning these units, I'll be in touch with you. I would like to come and physically see and enlighten myself with the knowledge and the developments you are taking it forward. Thank you very much.
Thank you, sir.
Thank you, Mr. Rao, and I'm available for any local this thing. I can take it forward. I have picked up a lot of things with Hans. I had been surveying many plants in India, and the findings are almost similar what he had been mentioning. And we actually need this, and this is I see it as a cause to do it for Indian power plant.
I'm in touch with various power stations, and everywhere the same problem is there. And then I have the problem of ash utilization and all these things, and the increased coal consumption, and their the balance sheets are getting heavier with low load operations. So
also the money can be recovered. That is what exactly is mentioned. Your coal flow saving itself will pay you back all that spent. And so I think it's a very, very important. I insisted Mr. Hans to join this.
Great to have him over for the session. Offline, we'll be in touch with you. Thank you very much.
Sure.
We'll listen to the other panelists. Thank you.
Sure. Thank you so much.
Now I call upon Mr. Deepak, GMR Aurora, for zero liquid discharge. You all know that December 2015, the standards for water consumption has been further tightened. For every megawatt of energy generated, it has been clamped to 3.5 meter cube per megawatt. And for new power station, it has been reduced to 2.5 meter cube per megawatt. GMR team has worked considerably on this. Let's see with GMRs how they have achieved this, and some more insights onto this topic. Thank you. Please go ahead.
Thank you, Rao sir, and the CI team for giving this opportunity. And I welcome all the members who are present in this session. Basically, this zero liquid discharge is kickstart in the 60s around.
Mr. Das, may I request you to please share the screen and not the application?
Now is it okay?
Yes, sir. You can put it in full screen. Yeah, good to go, sir.
You can make it full screen.
Yeah. Okay. This zero liquid discharge basically started from a Clean Water Act in 1972, where there was a control for the polluted discharge in the effluent that was discharged from the industrial and thereby the controlling the pollutant in the discharge water. And subsequently, due to the scarcity of this water and the increase in uses, had gone for a MLD, which was a minimal liquid discharge. Further, for more control over that, it had gone for a zero liquid discharge. And now with this technique, it is mandated to get the norms which are government and norms which are government are giving a allowable permissions for 2.5. So to achieve that, we need to have a ZLD in our plant itself. And the motivators and the challenges are many, which are need to be addressed during the opting of ZLD technology, because of huge amount of technologies available in this system. Basically, it has the three following components, and the pre-treatment sections, it is a physiochemical biological process which is getting involved, and the reverse osmosis process, which is more prominent and is established, and further it is more reliable in the plant, operate with the controlling parameters, and subsequently, at the way forward, the evaporator and crystallizer may be applicable in future. Then to go forward with the RO systems, which take care of all the effluents which are present, there are certain challenges for the chemical selections in that pattern. Basically, if we go with the pre-treatment sections, where particularly the RO takers of the major discharge, and these are the key steps where the ZLD process is taken care of, like pre-treatment, evaporation, and crystallization. In a nutshell, if we say this RO is basically the more reliable technology available for desalting, and the purpose of this is to require more water from the system, and this cost totally depend on the recovery of the RO, and the recovery of the RO subsequently depends on the three factors, that is the osmotic pressure increases with increase in the TDS in the effluent of the water, but subsequently increase of DP, the two factors which need to be addressed, whether the increase in pressure is observed in the first stage or the last stage. In the first stage, then it can be because of the chemicals which are getting carry forward, like in first stage mainly we found the coagulants which are used in the pre-treatment section. If it is found in the last stage, then that will be the probability of the scaling or the ineffectiveness of the antiscalants which are used for this. And in the scaling also, calcium magnesium sulfates are being taken care or addressed by the antiscalants present in the market, but particularly for silica there is a limitation like that. And if we are treating the cooling tower water in the our system, then there is a stiff challenge for the phosphate as well as silica, as the single antiscalant is not available to take care of both the chemicals. So contents are controlled by the lime dolomite process in a clarifier only. We subsequently reduce around to 45% of that content in the effluent. And the following of the inorganics, is taken by proper chemical dosing of the basically the schematic drawing which is shown. If we address this is particularly for the total dissolved solids in the water, and the same is being addressed where it was for the suspended solids. Like if we replace the RO with the clarifier, lamella or tube settler, and the brine concentrator with the thickener and crystallizer with the centrifuge, the scheme will be same for the pre-treatment section where we are removing the suspended solids. So that is being achieved for a zero discharge in the whole, and without any wastage of water in that. Recovered from the centrifuge are presently used as a manure in the field, because the capacity of the sludge which are being generated has a higher retention for water, which is helpful for plants to grow. But this is particularly we have to think of for brine concentrator and crystallizer, which will subsequently add value to the existing RO, where at present the RO concentrator are being used in the as handling system or coal handling system for spray or dust separations purposes and normal thermal. So these are the in total the few ZLD which is being implemented, and the extra which can be thought of. Basically, GMR is more focused on this, and at the design stage only considered this ZLD system in the project itself, and they have a good RO plant which can take care of this. And before to that, they have a clarifier which is subsequently reducing this silica and cooling water treatment. This is the GWL at a glance, actually, the capacity. This our plan is more focused on this, and they have a separate water management policy which actually provide the guidance to all appropriate steps that are to be taken or comply with the due to manage water system within GWL along with the nearby areas, and also comply with the legislation approved codes of this guidance relevant standards, and ensure the procedures are implemented to ensure the safe, reliable water supply, storage institutions, and conservation systems. So this is being addressed to each and every employee. This is the water management or the water balance or GMR program, where we subsequently reduce our water by different systems which are being used in, and effluent which are being generated are the treatment, ROTM, calculating system, and domestic waste, and their generation points are being addressed and they're properly taken care of, so that we can have a minimum wastage of water and reuse the subsequently generated water in the system. So this is the pre-treatment sections where the centrifuge is giving the solids which are again being used in the greenbelt sections as a menu, and RGCF backwash water is reused in the system itself, so there is no wastage of water in the system, and only the RODM which we are getting that are also being used, like RODM reject we are using in our MGF backwash water, and the second RO2 is there, which is used for generation of DM water. That reject is being recirculated back into the system, so that we can minimize the waste generation, and the minimized water which are being generated are used in ASP and assembly plant and coal handling plant. And the circulating system which we are getting the blow down water, for that we have a effluent recovery system, which though a challenge, because to control the 4 doses in the system by dosing the lime as well as the dolomite at appropriate content, reduce the silica, and parallelly also to control the turbidity, because the increase of dolomite and lime in the system, parallelly it increases the turbidity to 5 to 6 than the inlet water. Again, to suppress this, we need to add the coagulant and flocculant at a balanced way. So to conduct this for the 4 constituents for the same sample gives a little bit, let's say, a tough job, but still we have managed to establish the system after a very good study with all the team members, GWL, and now successfully we are complying this system in place with a recovery of around 70 to 72% in the RO, and we are in the strike for improvement of that recovery further, with finding the alternative anti-scalants available in the market and carrying out the different trials in that. There is the schematic drawing of the water balance of the domestic waste, and there is the effluent generation. Now, GWL is more focused on the measurement, monitoring, and the review system mechanism is well in place, and we have established this with proper accounting, and this accounting is done by installing around 32 flow meters in different pipelines which are used, and monitoring it through SCADA system is a new technology introduced in this, and reviewing mechanism as on daily basis we are generating financial reports, and review mechanism is based with weekly fortnightly and monthly. This is the effluent handling system for cooling water blow down, where we have a separate pre-treatment section and the clarifier, and from there we are recirculating back to the cooling tower through MGF and URO system. And sometimes when the fire water system needs some makeup, the same water is given for the fire water system makeup also from the cooling water system. Basically, in order to attribute water consumption at different areas and to study the water consumption pattern, GWLH install these meters at different distribution points. The real-time values are as well as the history of these flow meters are available. Water SCADA installed at the central control system, and the local PLCs also monitored to understand any deviation, if any, and these are being properly addressed. A dedicated water SCADA system is mounted to only monitor the continuous online monitoring of the water users. This helps our managers to track the water consumption and identify any wastage or any leakage in the system, thereby reducing the wastage of water. These are three reports which are being generated and are reviewed on a regular basis. So we have prioritized this water consumption pattern also, and each members are being credited for any identified SIPs or SIPs are being conducted to minimize the water loss in the system. And these are the processes being followed to quickly address the defect points if identified within the system. Now, for the sustainability towards water consumption, performance are evaluated and set a benchmark and adopting the best 200 practices, and to have encouraged every members to participate in all the attributes, and to have these are the features which we are justifying the uses of the wastewater, and the rainwater harvesting is the way of collected this rainwater in the roof buildings and reusing in the filter makeup. To 19 projects which are being 18 projects which are being addressed and modified the system to preserve water. These are the SCADA systems which are being implemented, the rain harvesting and display boards, and this is the specific equipment which we have got in the recent times. So we reduce subsequently to 2.2 meter cube per megawatt. Now the benefits are so many which we have already implemented and already have a saving of specific water in terms of cost as well in terms of specific utilizations of energies also. Thank you.
Well, thank you very much, Mr. Deepak Kumar. Nice work is being done there on ZLD, and it is nice to hear that you are well below the statutory conditions by Ministry of Power and MOEF and CNC, and the overall process approach is being followed for achieving ZLD. Keep it up. Thank you very much. We'll take some questions at the end. And now I come next topic is NOx control for thermal power station from Fortum Group, Mr. Halapa.
Thank you very much. Let me share my screen. Okay. Am my presentation visible now?
Yeah.
Okay. Okay, thank you for the opportunity to give a presentation and about NOx control for thermal power plants. Is my voice audible? Enough? You can hear me clearly?
Yeah, it's okay.
Okay,
Go ahead.
good. Okay, so first of all, well, my background is engineer, and I've been working for Fortum now over 30 years, and basically very much on power plant environment in the beginning on the basic engineering side and R&D side even, but then later on international O&M management, and then also I was working in our company in the distribution network side and then nuclear side. And now I'm responsible for our business development in Asia, including India. What comes to Fortum as a company, so we are energy utility working and operating in more than 10 countries, mainly in the northern part of the Europe, but also in Russia, Poland, and we are also present in India. And we have all kinds of power plants, which I come back into a second. We are stock listed company, even though, well, we are owned 50.2 or slightly above 50% by the Finnish government. And what comes to energy production, like I said, we have different type of power plants. What comes to the power generation, then we have natural gas, nuclear, and hydro. What actually is something, what comes to coal, nowadays we don't have much coal production anymore. If you look at this picture, let's say 20 years back, then you would find that the coal would have represented 30% of our power generation portfolio, but nowadays this is going out what comes to the only power generation side. Then if you look at the heat production side, because of the northern location in the northern Europe, there's a lots of district heating systems, and which means back pressure turbines and all that. So we have much more versatile fuel selection there. It also includes still some coal. As a company, anyhow, we are working towards CO2-free production as in many other countries and places in the world, and that's why, of course, that will become less and less in the future, of course. But what I try to say here is that we have extensive experience on the coal-fired plants. What comes to our Indian operations, there in India actually, then currently we are looking at very much on developing solar plants, and at the moment then we have 685 megawatts solar portfolio, and we are targeting towards 2 gigawatts. In addition to the solar business in India, we have EV charging and biorefinery where we are doing ethanol from bamboo in Assam. And then in addition, we have what we call energy solutions, but this means business unit within Fortum, whereby we have certain technologies and capabilities regarding power plants and mainly thermal power plants. We are supporting here also our own power plants, but also then we are providing these technologies and services to other companies. And going then further towards this NOx technologies, then Fortum next, we consider ourselves OEM and forerunner in the novel combustion technologies, and we started with our own power plants already 1991, 1992. We already worked with our own power plants, coal-fired plants. Like I said, we had much more coal-fired plants at that point. We realized that as a power utility, these emission requirements were getting tighter and tighter, and at the same time, our boiler manufacturers either had disappeared from the market, or the solutions which were available we considered were far too expensive or didn't fulfill our other requirements, what we had as a power utility for our coal-fired power plants. Once we had done our own fleet, we started to provide these services to other companies, and we worked quite much in Czech, but also in Poland. And nowadays we have actually done more than 1,000 low NOx burners and NOx reduction projects more than 50. What we are looking at and what we have proven combustion solutions, looking at emission reductions, performance optimization, fuel conversions also are in our capability and technology. From utility perspective, we have always been very sensitive and we have been looking at very carefully both CapEx and OpEx. And we are also, of course, independent from OEMs what comes to the boiler manufacturers or such. And we have our own patents and licenses for our technologies and solutions. And we keep on developing this because we consider and we have found this kind of approach very important for utility like us in order to keep us competitive in a competitive market. Going deeper to combustion side, so this is just a sample of our know-how and why we are claiming us OEM what comes to the combustion. So we have our own burners and solutions for the combustion for different type of boilers and different type of fuels. What comes to these low NOx reductions? So first of all, what I'm talking about today is the primary method, and Promecon also was talking about primary methods earlier, and I think this is quite nicely fulfilling or expanding that what already Promecon started earlier. So first of all, among those 50 projects we have done, these NOx reductions, it's good to mention that we are not specifically looking at certain type of boiler OEM or boiler types. We are able to do these things for all kinds of boilers with all kind of ages and all kind of sizes. So our approach has been always that we want to cover all our power plants, and they tend to be different sizes and different make, so we need to be capable to manage them all, and that's why we have developed our capability to be able to do tailor-made solutions for each boiler. Because we know that even if they are same make and same size and all that, they are still different. What comes to India, then at the moment, these are the limits for the NOx emissions. As of today, I don't go and discuss any further about whether they are going to be changed or not, but that's as it's of today. I think the important thing there is to understand that whatever the limits are, then what kind of solutions and how should I approach this NOx reduction in general. This is quite common kind of information, but just to highlight that, okay, when we are talking about different methods, then we are having these primary methods, and then we have secondary methods where you are working further up in the boiler, and when you are when you are having SNCR, then you are putting urea or ammonia to the upper part of the boiler, and then SCR technology is then something which is quite much bigger arrangement in the end of the boiler. How we are looking at these NOx reductions versus all kind of NOx technologies available. So if you look at starting points where you are today with the NOxes and you look at the technologies, how low you can get, this is how we are normally looking at this and what should we do. And specifically today, I think we are looking at this area where the NOx levels, at least in India, this is what I've been looking at, have to be somewhere anyhow between 500, 400, 300, 200, even down to 100. So you are looking at what we are saying that are called simple primary NOx reduction methods, state-of-the-art primary NOx reduction solutions, and then where you have secondary NOx reduction solutions. But we wanted to highlight here that you should always look at secondary NOx reduction solutions together with primary. This is very important issue. Why is that? The reason being that having the proper primary NOx reduction technology, you will ensure that you have minimum capex and opex. This is the kind of key message we have learned during all these 30 years time when we have been working with our power plants and trying to see what's the best technology and how to approach emission reductions. What comes to the NOx reductions, we have already seen that 200 milligrams per cubics can be achieved with state-of-the-art primary NOx reduction technologies. And you could quite easily say that 300 milligrams can be achieved for most of the cases. Whichever the case, then anything which is remaining, if you have to go lower, then you need to go for the secondary methods. Like I said earlier, it is important to note that 100 milligram NOx reduction by secondary methods means substantial OPEX. And if you compare that to CAPEX, it has a big portion. That is sometimes surprising how much the OPEX is compared to CAPEX when you go and start talking about secondary methods. And this is something we have really learned hard way sometimes as well, that it's very clear that the emissions will be lower, requirements will not be any looser than today. There are always new coals, always new requirements. You will get cheaper coal from somewhere, different coal from somewhere. And again, nowadays already mentioned in this Promecon's presentation that this flexible operation, because of increasing amount of renewables coming in the market, you have to be ready for these things. And whatever you are deciding here regarding NOx reduction, you have to look at it in this context. This is our learning curve as a power utility, very strong one. Now, if you look at then this selection a bit further, so SNCR case, these figures here, these are now in euros. Sorry about that. Could have, of course, used crores or something, but nevertheless, they are indicative anyhow, and just to illustrate anyhow the ratios of these issues. If you look at the simple primary NOx reduction solutions, you are talking about certain amount of capex, and then you can reach certain level. Whether it's 400, 450, 300, depends on the case. I'll come back to that a bit later. Then if you are investing a little bit more on the primary NOx reduction solution, you are of course having higher capex, but you can reach a little bit lower. Then when you actually what comes to the secondary systems, then it's really important to realize that if you want eventually, or you need to, for any reason actually, then get lower than you thought, or your situation is changing, the SNCR investment is going to be something which is equal. It's an other, you will double your capex requirement. But it's not only that, you are actually on annual basis, you are having a lot of OPEX spent, and it can be as much as your original investment. So easily within a year, you have spent same amount as you originally invested. If for any reason you need to go lower than you thought with NOxes. And then there are some technical limitations, of course, that how far you can go with SNCR technologies to start with. So SNCR has certain limitations, how much NOxes can be reduced, but this is a little bit kind of theoretical case, this right-hand side case here. So I'm not going to repeat that one. Then what comes to SCR, it's very much a similar case. But in SCR, you just have much more initial capex requirement. You can go basically as low as required to meet any requirements nowadays in any country. You can go with SCR. But it will, again, come with certain capex and certain OPEX. What comes to India, of course, how long catalysts will last and all that with Indian coals is, of course, big discussions ongoing, and this is good that this discussion is ongoing. But anyhow, from when you are looking at these technologies, this is important to understand this. Then what comes to Indian coals and NOx reductions, we have looked at many Indian coals and how we should deal with this NOx technology selection. We have compared them with other coals we have been familiar from the past. And the conclusion anyhow you have to make what comes to the coals, that Indian coals from NOx reduction point of view are not worse than any other coals. They are actually mostly relatively easy from NOx reduction perspective. And but what's really important to understand that coal quality has a big influence on the NOx is what comes to primary technologies, and you have to really look at carefully that what coals you are using, whether you have blend, you are able to blend them and all that, because if you're always looking at your worst coal from NOx reduction point of view, then you need to really understand that is that your requirement or not when you are looking at the worst case, that when you have to comply with NOx requirements. Those things what comes to coal quality, which are important elements for NOx reduction by primary methods, is nitrogen content, volatile matter, and fixed carbon. Then the other key issues, also some of those mentioned by the Promecon, you need to be aware of that the milling operations and air and coal distribution to your boiler, and what burner levels mills are in use, they have surprisingly big influence on the NOx levels, and you need to be sure that all these kind of reasons which are varying your NOx levels are considered when you are specifying and deciding that what technology fits for your plants. What we are doing is that typically we have seen that in India the boiler is they have some overfiring systems which are typically called COFA, coupled OFAs we call them, and typically there are no, at least most of the boilers, they do not have any separate OFAs, SOFAs. The separate OFA means that you would have air supply a little bit further up in the boiler, not immediately above the topmost burner. In order to do these NOx reductions efficiently, then our concept has been that in order to ensure that the boiler operates reliably, you need to not only introduce new overfiring system, you also need to modify burners, and quite often we have been changing the burners totally, but in India we have seen that it would make sense. It makes sense to modify them only, at least if there are no other reason to change those burners. Modification is sufficient, but you have to look at both those things together in order to make sure that the boiler also is working reliably, both in full load and part loads. Okay, this is our typical low NOx delivery process, but here downtime we are talking about is from 4 to 6 weeks to do such a work. I don't go to any further details on that. So that I have time to show a few references from India. So we have done boiler optimization work for CLP Jajar, and they have 2 Harbin boilers there, and for them we carried out boiler combustion optimization. So we didn't do any hardware modifications, and the reason for that was that that this power plant, already the boiler was one of those rare cases, considering the age of the boiler, that it had one level of SOFA there already.
Mr. Holland, we have to conclude now.
Yes, this is fine. So conclusion was that we managed to, by optimization, we managed to reduce NOx levels less than 300. And this is information from the customer after the project that they have fulfilled this 300, almost 100%, purely by optimization. Then one of the projects we have done is Hindalco, and this is the latest project still ongoing. It's 150 megawatt PHL boiler. And there we had very hard condition. We have to meet 290 milligrams in all loads, all mill operations, any coal they are using. They are using Indian coal. And unfortunately, COVID-19 has prevented us to do the final PAT. But based on initial provisional information, we can already say that during 3 months operation, when it has been operational after the works, we have met 300 milligrams less all the time. These are daily averages. And unfortunately, I cannot reveal exact numbers here, but this is a good indication and demonstration that 300 milligrams limit can be met. Okay, thank you for this. This was my last slide.
Okay, thank you very much. It's a wonderful presentation on how to address the NOx issues. As he has rightly said that the norms have been stringently set for the power plants. The power plants which are already running, it has been reduced, and the new power plants, as Mr. Alapa said, it has been very reduced in a very drastic way. It is a challenging for everybody to adhere to this, but I'm happy that he's able to give some solutions, by way of optimizing the performance of the boiler, and then primary initiatives like using low NOx burners, and considering all the requirements. It is the case-to-case basis. You'll have to see for each power station what is the amount of NOx to be reduced. So he has given a very big insight of the issues related to NOx reduction and the technology available. Thank you very much. We'll wait for the audience to raise some questions. Thank you.
Thank you.
Today's last session, the environment management strategies and action plan by Mr. Sudhir Daya from NTPC.
Thank you, sir. First of all, I will thank to the organizers for giving the opportunity to share the whatever efforts my company is doing for environment along with power generation. Is it visible?
Mr. Daya, please share the screen, sir, not the application.
I shared the screen only, sir. Is it okay now, sir?
No, sir, please share the screen. The application is visible.
Is it okay now, sir? Sir, is it
Yes,
okay
sir.
now? Yeah.
Yes, it's okay, sir. You can minimize the WebEx small windows.
Yeah, I will minimize that. Is it okay now, sir? Can I go ahead?
Yes, sir. Good to go.
Yeah, thank you, sir.
Please go ahead. Yeah.
Respected Rao, sir. Today I will share the whatever we are doing for environment along with producing power from all type of sources, not only from coal or gas. These days we are in the business for. In our portfolio, we are having all type of sources except nuclear. Basically, environment management strategy is inbuilt, that is imbibed in our system through company's vision and mission. And in environment management and resource conservation, the basic requirement, or we can say statutory requirement, is environment policy. But in addition to that, to contribute to environment and specifically for resource conservation, our company is having a dedicated water policy, then rainwater harvesting policy in 2018. We are having dedicated biodiversity policy in which we are already executing 5 to 6 projects at different stations. We are having integrated plastic management policy for basically to minimize the single-use plastic, and whatever the old we are having in any form, how to recover either energy or resource from those waste. And waste management is a area which is considered a little bit neglected in the sector, but in our company, this area is always taken on the top priority. Either that waste is coming from construction and demolition of any old structure, or from our construction activities, or any hazardous waste, e-waste, biomedical waste, or any type of waste. Even the waste which are not regulated by any of the rule notified under Environment Protection Act. And we are having a dedicated zero deviation document for waste management. This is the only document in the company whose name is given as zero deviation. It means there is no deviation is permitted in any circumstances for managing the waste. This is the vision of my company, to be the world leading power company energizing India's growth with the mission provide reliable power and related solutions in an economical, efficient and environment friendly manner driven by innovation and agility. How? I will discuss today. In our environment policy, our policy is to provide the cleaner energy by committing to the highest possible level of performance. It is not only whatever the regulatory levels, highest possible level, even beyond just compliance, in environmental compliances, practices, and stewardship, for controlling air pollution, water and wastewater management, waste management, and plantation and biodiversity. Plantation doesn't mean in our company is green belt development. We are doing much more than that. In actions, in our all stations, we are having inert features at the time of inception. Those are finalized and imbibed at the time of awarding the package, either that is EPC or other ways. These are the inert feature. Adoption of more energy efficient technology with time. You will certainly appreciate the efforts of the company. In 99 at Vindhyachal stage 2, our efficiency was somewhere 38.6. And at Khargone, our efficiency is 41.55%. And we are in process of advanced ultra supercritical pilot. And we are expecting that definitely we will achieve this as well. And everybody knows that every 1% increase in the efficiency yield in 2.5% CO2 reduction. This is an effective reduction in CO2. Because this parameter is not regulated, but still the company is having own targets that how we can minimize our carbon footprint, specific carbon footprint to be very specifically. Those will be reduced by adding the renewable and by increasing the efficiency in the thermal. Then, high efficiency ESPs, definitely when the new notification came in 2015 and many of our projects were under erection, definitely we are having the issue with the SOx and NOx that we have to go for a FGD and DINOx system, because those units were planned that they will be commissioned after 2015 and the new norms will be applicable on those. But in case of particulate emission, that was not a issue at all, because due to proactive approach towards environment, our engineering team already designed the ESPs which were capable and which are capable to meet the norms 30 milligram for the units which were awarded prior to notification of 2015. Then R&M of ESP in the old station wherever required. And for those units also, there are more than 10 units in which R&M is done, and the levels applicable as per new norms are 100 milligram. But those R&M were done keeping the level that we have to achieve 50 milligram, as state regulations are 50 in those states for the particulate emissions. FGD for all new units to control the SOx and NOx emission. Pilot studies are that completed, and a report is submitted to concerned ministries for consideration the outcomes. Dust extraction and dust separation system in all dust prone area, either that is CHP or dike area, coal unloading to coal feeding on the entire coal parks. We are having the educate system. Those are inbuilt in all projects. ETP and STP to recycle, treat, recycle, and reuse the effluent for maintaining the ZLD. And ZLD is not the mandatory condition. We are not considering that only the units which are commissioned after new notification, where there is a statutory requirement. Our management is having agenda prior to that, and we are in process to achieve ZLD at all stations, irrespective of their commissioning date. And we are in process of modifying them, and already 13 stations of NTPC, in which 9 stations are old stations, already achieved ZLD. For coal handling system, CHP area, we are having a closed circuit with CSSP that no water, no effluent, even after treatment, should enter in any other circuit in the power plant. Then dry ash taxation system is one of the top priority, because ash utilization, everybody knows, is a big challenge in this sector. And our units which are older, and at that time, those were not conceptualized that there should be DAS. In augmentation, we are in process to equip all the units irrespective of their commissioning time. All are equipped with DAS system to maximize the ash utilization and minimize the use of natural resource like water for disposal of that, and energy consumption for the disposal of that slurry to the dikes. Adoption of high concentration slurry disposal for water conservation. Then ash water recirculation system for bottom ash disposal, and in case of old station where medium or lean slurry disposal system is still operational. Inbuilt ZLD scheme for all new projects, and we are augmenting the systems to achieve in older units. Waste storage and management facility along with the main plant. Those are kept in mind, and in first GLP itself area is demarcated that in which area it will be there, and what will be the mode and what will be the type of facility will be created in the plant. Green belt demarcation and development during erection phase only, and additional plantation in the nearby area. That is not a statutory requirement or part of any condition or legal requirement. Air pollution control during operational phase, because installing FGD, DINOx system or PM control system, that is ESP, only installation is not going to meet the requirement and achieve the targets. Operation of ESP, optimum design efficiency, dedicated team for check and control of APC equipment. Operation of FGD, because we are having one operational FGD at unit 13 at Vindhyachal. Combustion optimization tuning to minimize thermal combustion. Operation of dust extraction system in CHP, ensuring the operation and availability. Fugitive dust control at ash dike, either by maintaining the water cover or installing sprinkler system or vegetation cover in the ash dike. In best practice, we are having a water curtain wherever we are handling ash, either that is silo area, or we are using pond ash from the dikes for NHAI embankment work. We are issuing that ash, and we are even supplying that ash to maximize the ash utilization. Vehicle washing facilities, avoid any fugitive during transportation of fly ash. Transportation of ash, cement, or any other construction material in the covered vehicle only during either it is during construction or during operational time. In case of water and wastewater management, during operational phase, continual improvement in COC, even in old station where we are in compliance to specific water consumption. At all of our stations are having specific water consumption in range of 3 liter plus minus 10%, maximum 3.3, and we are having the best station having 2.15 liter per unit generation. Still, our management is insisting that we have to achieve more COC to minimize the specific water consumption and make the ZLD compliance more comfortably. Operation of central effluent treatment plant with optimum efficiency and recycling and reuse of treated effluent to ensure ZLD all the time in all seasons. Augmentation and replacement of old STP, because with time requirements are revised. Operation on optimum efficiency of those STPs, pipeline network for reuse of STP treated effluent either in a forestation or in dust separation in CSP area, we are using that water. Recycling of 100% decanted water from ash dike using ash water recirculation system. Recycling of towed rainwater, because this is an inbuilt feature of earthen embankment dikes. And the water is coming to towed rain, even though that is qualifying the all criteria of effluent which are prescribed by the regulators. But to maintain the ZLD from dike area also, we are having the dedicated towed rainwater recirculation facility at all stations, and we are not allowing even the water from towed rain to any nearby area or any water body. ZLD discharges by recycling and reusing the treated water from STP, ETP, towed rainwater recirculation system, and rainwater harvesting at all stations. And this year, we are expecting that we are going to achieve the rainwater harvesting facility for 50% of the harvestable quantity as per our rainwater harvesting policy 2018. All stations will certainly achieve that target, and company at company level, definitely we will beat the target by a big margin. ZLD at all stations, NTPC, irrespective of statutory requirement, as I told earlier, that 13 stations already completed, and we are expecting balance will achieve in 2020-21, but due to COVID, 2 or 3 stations may go next year. But definitely by next year, June or July, if things will be in line, we will achieve at all stations, irrespective of their date of commissioning. Use of fogging system in wagon tippler and TP to conserve water, because earlier there was a water sprinkling system and consuming more water, and water handling and treatment that was giving additional burden to our ZLD system. Then the system of fogging system, and these are additional provision made to avoid the use of system which are consuming more water. Then ipomium and other plantation in ash dike area to control fugitive from ash dike area and to minimize the water cover. It is also effort to reduce the water consumption, because that will minimize the evaporation losses from the dike area. As early mentioned, use of towed rainwater and decanted water in sprinkling system to control the fugitive dust in place of maintaining the water cover. We are coming with air-cooled condenser in new projects, Patratu and North Karnpura, and we are also going to have that ash mount at Patratu project after we are having a successful example of ash mount at Dadri.
Mr. Sudhir, you have to conclude now.
Okay, sir. Then in case of new emission norms, is already awarded more than 60,000 gigawatt, out of which 5.5 gigawatt is operational and 840 gigawatt commissioned and ready for operation, and 2.48 gigawatt is in advanced stage, and we are expecting within next 3-4 months these will be operational. And the additional 2.8 gigawatt plus is in NIT. Part is in award stage and part is in tendering stage. Combustion modification for is already awarded and in execution at different stages, and we are expecting that we will achieve in time. Pilot study already completed and report submitted to the concerned. ESP upgradation, wherever the old units are there, all work is awarded, and we are in the stage of implementation in the balance 13 units. Remaining our work is already completed. And these are our targets, that our current emissions are in 1920, specific emission for PM is 0.31 gram per kilowatt hour. And for SOx, these are 4.41 gram per kilowatt hour. In case of NOx, 2.11 milligram per kilowatt hour. In 2022, we are expecting that PM reduction for the specific will be reduced to 0.23 gram. And there will be a huge reduction, approximately 25% of the current value in case of SOx. And approximately reduction of 50% will be there, or we can 40% to be very specific for NOx. And by 32, that particulate emission will be 0.20, and there will be further reduction in SOx to 0.76 gram and NOx 0.99. We are expecting by 2022 and 2032, we will achieve our targets by implementing the plan we are having for SOx and NOx.
Yeah, thank you, Mr. Sudhir. It's an excellent presentation showcasing all the environment management initiatives being taken by NTPC, FGD, NOx, and ash utilization. You also shared some of the best practices, and you mentioned that NTPC is going beyond the statutory conditions, so very well appreciated. As such, Indian power plants are facing a challenging task to control the emissions, especially particulate matter below 30 milligram per meter cube, SOx 100 milligram per normal meter cube, NOx less than 100 milligram not normal meter cube, water consumption less than 2.5 meter cube per megawatt, installation of ZLD, and last but the least, it is 100% ash utilization. Most of the power stations, though they are doing a lot of initiatives in all these issues, while take up like ash utilization, some of the stations are doing well, and there's a lot to be done. NTPC is doing remarkably well in addressing the ash utilization. As Sudhir was mentioning, NTPC is already in the process of ordering for the equipment for FGD and NOx controls. Is a good sign. And in fact, the deadline given by Government of India, Ministry of Environment, Forest, Climate Change, the initial deadline was 31st December 2017. Somehow it was missed by all the power plants, and a bit relaxation has been given, and most of the power plants are gearing up to meet these stringent environmental conditions. So with this, we are concluding the session 5. Initially, if you go back and see, Isgec has given a wonderful presentation how they are supplying the GDs and how they are able to do it, and then followed by Promecon and Mr. Shukla. They have given a wonderful presentation, optimization and fine tuning of cold flow and air flows, and followed by GMR, regarding ZLD, and Mr. Alopa has given how to control NOx by way of primary methods and secondary methods. Altogether, it's a wonderful presentations given. I request Sanjeev to take up the questions if it is any there, the individual speakers. Sanjeev, you have any questions logged from the participants? Hello. Hello. Sanjeev. Hello, Sanjeev. You are able to hear me?
Yeah, I can hear you, sir. Can you hear me?
Yeah, please go ahead. Any questions there from the audience?
Yeah, there are two questions, sir.
Yeah.
We have a couple of questions to Isgec team, Mr. Soumik and Mr. Amit. Just read it out, sir. Mr. Soumik and Mr. Amit, what is the expected life of bag filters? And what is the best efficiency of a CFB system? Mr. Soumik, if you can just unmute and switch on the video, please.
Hello.
Yeah, Mr. Soumik, can you hear me? Mr. Soumik, you are on mute, please. Please unmute.
अरे यार इधर आना अनम्यूट कैसे करना है इसको वो स्क्रीन दिखा रहा है
Please don't, sir.
अनम्यूट कैसे करेंगे इसमें नहीं रुक जा
We are able to hear you.
hello 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 can you hear me
Yeah.
Yes, Mr. Soumik, we can hear you.
okay
So there are two questions to you. First is, what is the expected life of bag filters? And second, what is the best efficiency CFB FGD system?
Back filter life typically 3 years is the guarantee it is given is this the industry practice typically, and maximum capture it depends on how much is the inlet. It can go even 95% plus, 96 97 also it can go, 98 also it can go, depending upon what is the inlet and outlet is required. Lower the outlet, percentage gets reduced. Okay.
Thank you. We have a couple of questions to the Promecon team also. Mr. Hans George and Mr. Anup Shukla. Can you please unmute and switch on the video?
They are available now?
I think they have dropped off, sir.
Okay. The next question, please.
Yeah, there are quite a good number of questions to GMR Aurora. Mr. Deepak, if you can just unmute and switch on the video. Yeah, Mr. Deepak, question from one of our delegate wants to know where is the EQMS installed as per government guidelines?
Can you repeat that?
Where is the EQMS installed as per government guidelines? And secondly, if RO system is not working efficiently, what is done in such a case?
RO system, basically we go for the autopsy test where we find out what are the content of the depositions in the RO membranes to address that. Recently, I performed such a test 2 years back when we did this autopsy test. We found that the silica depositions was more in the membrane, and subsequently we addressed that problem and we changed the anti-scalent to a higher mode, which was a bit costly, but it was addressing the higher silica which was there in the cooling water. So chemical content which is deposited in the membrane need to be addressed by autopsy test only. And liquid flushing is done intermittently to avoid the biodepositions in the membranes whenever the membrane is in idle condition for a 24 hours or so.
Okay. What was the typical payback period for retrofitting of ZLD system? What is the capital and operating cost for per meter cube of water cycle recycle for ZLD?
For ZLD, including the power cost, right now we are getting around a cost of around 7 metric cube in compared to the service water and the RO water. That is the chemical cost as well as the power cost. In chemical cost, we are getting around 2.5 to 3 rupees, whereas the power cost is around 5 rupees.
Right. Thank you, sir. And we have a couple of questions for Fortum team, Mr. Jirki and Mr. Vikas Mehta. Can you please unmute?
Okay.
Yeah, sir. The question is, are there any efficiency changes in separate overfire air operation or NOx reduction at part load conditions?
In part load conditions specifically, then our experience, well, first of all, when you are doing the primary NOx reduction, then theoretically you are always talking about reduction of boiler efficiency. But our practical experience is, and it's very important for us, has been always that what happens to our efficiency when we are complying with environmental requirements, and therefore we have developed this technology that we are minimizing always this influence. But in practical terms, we have seen that in most cases the efficiency of the boiler has improved after the projects. And why is that? The reason is, and this is specifically in a part loads, if that was particularly questioned, that how about the part loads? In part loads, it's not only that we typically improve the combustion when we have these projects, when we are improving the process and making it more stable, but also this idea of why do we do the burner tip modifications, or we are looking at the burners as well, not only the overfiring system, is that that we want to make sure that that this boiler is working properly and reliably at the low loads as well, and without influence on efficiency. And actually, yes, in most of the cases, efficiency has improved in our projects, even though theoretically this is not the case.
And one more question. Actually, one viewer wants to know the principle of NOx reduction in burner. It would be possible.
If you are reducing, yes, I mean, definitely modifying and having these, well, there are different generations of low NOx burners, how they are called. You can achieve certain NOx reduction by changing and buying the new technology for the burner, but this is very limited. We have a kind of thumb rule typically saying that if you are only modifying the burner and doing nothing else, you cannot achieve more than 15% of reduction, 15%. And now looking at like requirements in India and elsewhere in the world, then you definitely are talking about totally different percentages which has to be achieved. So there's no chance to comply. That's our, I mean, of course, depends on your starting point, but anyhow, it's very limited what you can achieve only by changing the burner.
Right, sir. Thank you. Thank you, sir. And one last question to Mr. Sudhir.
Yes, sir.
Yeah, sir. One of our viewers is asked, as NTPC is the leader in power production, what is the expected expenditure done by NTPC in next 3 years, and what is planned by at least 2030?
Basically,
What is
I
the
look,
expected increase in
whatever
cost of
area,
energy?
whatever area I looked after, I'm not having that information. I can revert on the mail after getting from the concerned team.
Sure, sir. Sure, sir. Thank you. That is all we have the questions, sir, as of now. For any
Yeah.
further questions or queries, we shall get it replied by our speakers by email communication with them. So may I now request Prasad sir to kindly conclude with
Yeah,
his
thank
concluding
you very
remarks.
much for all the panelists. Today we had a wonderful session number 5, most important session. It's environment management. We have covered about 5 topics, one on FGD by Isgec, next on NOx controls, then zero liquid discharge, again NOx controls by Fortum Group, and then last one is environment management strategies and action plans by Sudhir Daya from NTPC. We had a wonderful session, nearly 1.5 hours. Of course, time is the limit. We cannot extend. In fact, this is a very wonderful topic. If we keep talking about environment management, there is no limit. There is so much to be done. So much is already been done. After seeing the performance of the power plants over the last 10 to 20 years, wonderful initiatives have been done by the power plants, achieved what are the targets set, and now going by the new standards, the power plant has to do a long way to go to achieve, because this is the commitment given by Government of India to the external world as such. And so is a challenge. I am sure with this enthusiasm and the technology available, we'll be able to achieve this. Best of luck to all the participants. Thank you very much for CII giving an opportunity to be available with these people to have knowledge sharing. Thank you very much.
Thank you. Thank you, sir. Thanks to all the speakers. Yeah, thanks to all the speakers for such wonderful presentations, and that within the limited time. A very special thanks to Prasad Rao sir for leading the session, and thanks to all the online viewers out there. On behalf of CII, once again thank you all. So before we close the session, we would like to invite all the viewers to visit our Energy Efficiency Summit Clean Technologies Expo, which is going on online on CII Hive platform. So we have more than 25 innovative technology providers showcasing their products and solutions at this expo. And also we would request all the delegates to visit and interact with the technology providers in this expo. With this, hereby we are closing this session, sir. Our next session will be starting shortly. We request all the viewers to kindly stay with us. Thank you, sir. Thank you all.
Thanks all.
Gaurav, thank you. Please close this.